Good morning. I hope somebody will join me today because I was just all by myself yesterday talking to a screen. Made me feel kind of weird. So hopefully someone will join me today. We are going to review for Module 11's test. I've got questions picked out that are similar to your test. I did want to discuss with you guys how you wanted to do the format for your test, but if you don't come, I'll probably just assign it for homework and be available for questions. So we're just going to go ahead and jump right into the review since you're not here to ask me any specific questions yet. I'd only received homework from one of you, so everybody else got a 0 for your homework grade. I really hope you guys can get on track and send me that so that you do well for the rest of the year. We're almost there. We have like 7 weeks left, I think. So hang in there, do your homework. You guys are doing a great job. I'm really proud of you. You're all very bright students, so you have a lot of potential. Don't give up just because you're doing class at home. This is homeschool, so you should be good at it by now. Hang in there, you're doing a good job. I'm here if you need me, if you have questions. Okay, so let's jump into the review. We are gonna start with our study guide, and question 1 is gonna be the first question that we're gonna answer. So first of all, they want you to define pressure. And I'm just going to share my screen so that I can write out some answers for you guys. And hopefully you will write them as well in your notes. Okay, so question number 1 in the study guide questions, and that's on page 278 in your student book. Question number 1 asks us to define pressure. I'm sorry, I'm just going to move this so I can type a little bit. Okay, define pressure. All right, the definition of pressure: force per unit of area. I'm not really sure how this works. I was hoping that I could make the box bigger, but for some reason it won't let me. Okay, so answer to question number 1, force per unit of area. And let's see, what's next? I went through and picked out specific questions for you guys. So everything I'm going to review today is going to be useful for you when you take your test. Okay, next question that I'm going to make up is, which of the following relationships is true? 1 atmosphere equals 101.3 kilopascals. 1 atmosphere equals 760 torr. And this is coming from that table that we talked about early in the module that had, I'll find out what page it's on in just a minute. 1 atmosphere, I didn't mean to put atom. 1 atmosphere equals 760, what is going on here? Millimeters of mercury. All of the above, or none of the above. So which is true? The answer is going to be all of the above. See if I can highlight that. Okay, I don't know how. Still learning with this thing, guys. Bear with me. The answer is all of the above. These are all true. And let me find what page that is for you. I apologize, this video is going to be a little different. It's our first test review on Zoom. Okay, let me find the page number for you so that you can look over that. All right, that is going to be on page 384 on the top, and it's table 11.1 units of pressure. And it's going to tell you everything that's equal to 1 atmosphere. So all of these are true. Okay, next question is going to be number 2 in your study guide questions that we were just on, okay? All right. So it asks us to write Boyle's law in our own words. Okay. Well, I'm going to write it in my own words. Let's see. I'm sorry. Bear with me, guys. I'm trying to help you out here. Okay, so there's a couple different ways you can write it. Pressure times volume is constant. Okay. You could also say as long as temperature is constant, when pressure increases, volume decreases. And you could also say as long as temperature is constant, when pressure decreases, I don't know why this is, Garrett, I'm gonna start over here. Hey, Garrett. Okay. How are you?
Good, how are you?
Pretty good. I'm glad you're here. I was all by myself yesterday. Let me, I'm trying to figure out how to make this so that I can write. Okay. So I'm just doing a test review for Module 11. And I'm starting on page 278 in your student book. Let me get out of this for a minute. Okay. And so far, I've done question number 1, which was to define pressure. And I ignored the second part of the question because we don't need it. These are all going to be basically answers to test questions. So I'm putting it all out for you. So that was the first one, define pressure, which is force per unit of area. And then the next question was, which of these is true? And the answer is all of the above, and that's based off of the table on page 384, this one here. I'm trying to write Boyle's law, but for some reason the text box isn't big enough, so I'm going to start it over here. Okay, so number 2 in your study guide questions, write Boyle's law in your own words. I'm going to give you a couple different ways you can write it. You can say pressure times volume is constant. You can say as long as temperature is constant, when pressure increases, volume decreases. You can also say as long as temperature is constant, when pressure decreases, volume increases. 3 different ways you can write it. Okay. Next, we are going to do, let's see. Which of the following describes Charles's law? This may or may not be directly from your test, so I'm glad you're here. As long as pressure is constant, temperature and volume are linearly proportional to each other. I'll write out the choices. Hopefully it won't take me too long. As long as pressure is constant, when temperature increases, volume will decrease. So remember, Boyle's law and Charles's law are the 2 separate laws that combine to make the combined gas law. So we just talked about pressure and volume. So Charles's law was volume and temperature. And the answer to that question would be, I'm sorry, where am I at? It's number 4. The answer to that question would be this one, the first one. So as long as pressure is constant, temperature and volume are linearly proportional to one another, because remember, volume divided by temperature is constant. So that would be your answer for that one. Okay. Next, I wish I had a better way to put this out here for you, but this is the best I got. All right.
It works.
Okay. As long as you're understanding. All right, next
It
question.
helps.
Okay, good. That's what I'm hoping for. If I just help one person, Garrett, you, then my job is done. Okay, what does negative 273.15, let me see if I can remember how to do degrees. Nope. Degrees Celsius, I'm just gonna put C. What does that represent?
Kelvin.
Yes, it does represent, there's a couple options here. 0 degrees Kelvin, or 0 Kelvin, not really degrees. Absolute 0. The temperature at which a gas, has a 0 volume. Or the temperature at which all atoms stop moving. Or all of the above.
Isn't it all of the above?
Yes, it is all of the above.
Okay.
All right, next we're gonna just jump down in the study guide questions to number 4. I don't think you need number 3. So the question is, what general rule must a careful scientist follow when extrapolating data? Do you remember the story we talked about with extrapolation, and it had to do with evolution? And we talked about how Darwin extrapolated a large amount of data. So the rule that you really need to follow, I'm flipping here to make sure I tell you right, is to extrapolate data only when the amount of data that you have is large in comparison to the amount that you're extrapolating. So you want to have a lot of data and just a little bit that you're guessing on, not the opposite. So you also need to know for your test the definition of extrapolation. And I'll go ahead and write that out for you. Let's see if I can find it. Okay, so the definition of extrapolation is following an established trend in the data, even though no data are available for that region. So you need to know that for your test. I really like that example because I never knew that before about evolution, so that was kind of cool. All right, so next question. What are the properties of an ideal gas? That's number 5 in your study guide questions. So let me erase some of this. What are the properties of an ideal gas? I'm flipping between the test and the review questions, so bear with me. Okay. All right, properties of an ideal gas. I think that is, let's find it in your book. That's on page 394 in your book. And let's see. Okay, so the test is going to ask you which of the following is a property of an ideal gas, so you have to be able to identify that. So let's just say what they are. 1, the molecules must be small compared to the volume of the gas. The molecules that make up the gas must be small compared to the volume available to the gas. The second property, the molecules must be so far apart that they do not attract or repel each other. And the third property is all collisions that occur must be elastic. I hope you can still hear me because you like froze. So your test may or may not ask you which of the following are properties of an ideal gas, and they're going to give you options. Oh no, I lost you. Well, hopefully you'll come back. And the options they give you is the molecules that make up the gas take up most of the volume. We know that's not true. The molecules are fairly close to one another. We know that's not true. And the molecules are always losing energy with one another when they collide. That's not true. So the answer is going to be none of the above for that question on your test. Hi. What are you doing?
Oh, I'm fixing to have to leave.
You're what?
I'm fixing to have to leave.
Oh, okay.
So I was trying to put my stuff in the car before I jumped off in it. Unconnected.
You can always come back and watch it later. I'm giving you test answers, so you'll be rewarded for watching.
I think I might have to do that.
That is totally fine. Go ahead. Have a good day.
You too.
Bye. All right, moving on. The next question I'm going to ask you is your study guide question number 7. What is standard temperature and pressure? So this is 7 on your study guide. Standard temperature and pressure is 1.00 atmospheres and 273 Kelvin. Okay. Next question, I'm going to go to number 9 on your review. Study guide questions, number 9. A liquid's temperature is lowered from 50 degrees Celsius to 10 degrees Celsius. Did the liquid's vapor pressure increase, decrease, or stay the same during that time? Well, when the temperature of a liquid is lowered, its vapor pressure lowers. So when temperature of a liquid lowers, temperature lowers. So the vapor pressure decreased. And I'm just going to see how that compares to a question on your test. Okay, so it looks like the opposite would also be true here, which is what you're going to need to know. So also, the vapor pressure for any liquid increases as the temperature increases. All right. It's weird to have no one here, no questions, nothing happening. So I'm just going to keep rolling. If you have questions, please text me or email me. I'm here for you guys. Don't ever feel like you're bothering me, because you're not. I'm doing nothing these days except for playing with my kids. All right, number 10. Actually, we're not going to do number 10. I'm just going to do a couple questions now that are straight from your test. Okay, so the question is, what is the temperature at which the vapor pressure of a liquid is equal to normal atmospheric pressure? What is the temperature at which the vapor pressure of a liquid is equal to normal atmospheric pressure? You should remember this because when we talked about it, we talked about how at higher atmospheres, your boiling point is going to be lower. So boiling point would be the answer to that question. The temperature at which the vapor pressure of a liquid is equal to normal atmospheric pressure. That is also known as boiling point. And we talked about that earlier in the module. Okay, another test question is going to be, which of the following is equal to the ideal gas constant? Remember I told you you need to memorize it? Well, here you go. So your answer, remember the gas constant is R, and the test is going to try to trick you because they're going to give you the same number and just different units for all of them. So if you remember, our units are liter times atmosphere, atmosphere divided by moles times Kelvin. Space right here so you can see it. All right, this is your unit. So that's the main part that you need to know. Okay. The next question that I'm going to go to, I'm going to skip around, is in the practice problems, and it's number 5. You're going to want to pay attention. This is an 8-point test question. Okay, so we're going to do that one together. Let me get to the recording class. Hang on one second.
Hey, everybody.
No one's there. Kevin says hi, but there's no one here, so it doesn't really matter. Hi for later. Okay, so number 5 in the practice problems, we are going to go ahead and do. Let me make some space. I'm gonna erase this. All right. So number 5 says, as part of an environmental experiment, the mixture of gases released from a smokestack is collected in a balloon. If the mixture is analyzed and found to contain 25.0 grams of SO2 gas, 13.1 grams of NO gas, and 3.5 grams of SO3 gas, what is the mole fraction of each component in the mixture? Okay, mole fraction. We have to refresh our memories on the formula for that. So mole fraction, remember, was represented as X, I believe. That's what they said. Let me find it in your book. Yeah, X equals the number of moles of a compound, and that's divided by the total number of moles in the mixture. Okay, so let's work on number 5 then, specifically there. I can probably just write it out for you. Okay, so first of all, we're given grams, so the first thing we're going to have to do is convert all of them to moles. So let's start with the 25.0 grams of SO2 gas. So 25.0 grams of SO2. That's going to be over 1. And remember, when we convert to grams to moles or moles to grams, we're always going to look at the periodic table and find out how many grams are in 1 mole of the substance. So because I'm going to moles, that's going to be on top. All right, let me look at my periodic table. S has a mass of 32.1. There's only one of those. I'm just going to draw a little arrow here. I'm sorry if it's messy. Hopefully you can understand what I'm doing. And then oxygen has a mass, I know, of 16, and there's 2 of those. Okay, so that's 16 times 2, if you can see my little multiply. Get my calculator. All right. So I have 32.1 plus 16 times 2. I have 64.1. Okay, so let me just erase all of that. I just want to show you how I got it. Okay. 64.1 grams in 1 mole of SO2. All right, we put it in the calculator. 25 divided by 64.1, because these ones don't really matter, remember? So it's just 25 divided by 64.1. And I'm going to get 0.39. So that's 0.39 moles of SO2. Okay, now I have one of them. Next one, let's do 13.1 grams of NO. 13.1 grams over 1 times. I'm just going to give it to you because I don't want to waste time. Sorry, I'm trying to find it. All right, of NO, because you guys should really know how to do this by now. I'm sure you do. I have full confidence that you know how to do it. Okay, so we're going to just find out how many grams are in 1 mole of NO, and that would be 30. You know, you would just find the mass of N plus the mass of O, and that's where you get that number. Okay, once you put that in the calculator and divide, you get 0.437, and that's moles of NO here. Last one, we're going to do 3.5 grams of SO3. So 3.5 grams of SO3. Oops, sorry. Okay, 1 mole's going on top because I'm going to moles. And I would just find the mass of S, the mass of O, multiply it by 3, add them all together, and that's going to give me 80.1 grams in 1 mole of SO3, which gives me an answer of 0.044 moles. So now I have moles. Do I have my answer yet? No, not yet, because it asked me for mole fraction. So I'm going to move over on this side. Okay, so to find mole fraction, here is your formula. Okay, so first of all, I have the number of moles of each compound. I just figured that out, but I do not have the total number of moles in the mixture. So what do I need to do? I need to add how many of each one to get my total number of moles. So 0.39 plus 0.437 plus 0.044. I'm going to type that out for you real quick. Total number of moles, 0.39 plus 0.437 plus 0.044. And that's going to give me 0.871 moles. Now I have my total, and now I have each piece that I need. Okay, so first, let me see if I can type it because that just seems to be faster. So let's do X for SO2, and I'm just going to write it like this. I hope you understand what I'm trying to say there. Okay, so the first one is going to be the number of moles in SO2, which is 0.39, divided by the total number of moles, which is here, 0.871. And that's going to give me 0.448. 0.448 if you want to be correct there. Okay, so we found the mole factor for that one. The next one, let's do the mole factor for NO. And that's going to equal the number of moles in NO, which was 0.437. 0.437 divided by my total number of moles, 0.871. That's going to give me 0.502. Okay, lastly, let's find the mole factor for SO3. SO3. And we're going to do the number of moles of SO3 divided by the total number of moles. And if you put that in your calculator, you will get 0.051. And that's your answer. That is your mole fractions for each substance. And that was, again, practice problem number 5. You will have a question just like this on your test. So as long as you know that you first of all have to go to moles first, and then as long as you know your mole fraction formula, which you should have because you'll be doing your test for homework so you can use your book. Just plug your numbers in there. Don't forget to add up your moles to get your total number of moles for the whole mixture. And there you go. All right, next we are going to practice problem number 7. This is going to be a 4-point question on your test. I'm going to go ahead and erase all this so that I can do the next one. I might as well just clear it. That's going to be faster. All right, so number 7 in your practice problems. A steel container is filled with 10.00 ATMs of nitrogen, 4.00 ATMs of oxygen, and 1.00 ATMs of argon. What is the total pressure in the vessel and the mole fraction of each gas? This is interesting because it asked me for mole fraction, but it only gave me pressures. It did not give me grams, and it did not give me moles. So there's another formula that you learned, and I'll give you a little helpful hint. On page 410 in your book, you will see, I highlighted it here, I don't know if you can see, all the formulas that were needed for the module that I kept using so that I could just go back to that page and see them. So you're going to use equation number 11.11, and that's on page 400 if you're following along in your book. And that tells us that if we have the pressure of each gas and the total pressure of a mixture of gases, we can find out the mole fraction. So that's the formula we're going to use. I'm going to type it out in here for you. It's going to be the pressure of one substance is equal to the mole factor of that substance times the total pressure. I'm just going to put PT for total, the total pressure of the mixture. So let's do that now. Okay. All right, so first let's find each thing for our, let's find each piece for our equation to plug in. So first let's find the total pressure. So the total pressure is gonna be, I'm just gonna add up the pressures for all of the gases that they gave me. So 10.00 ATMs, 4.00 ATMs, and 1.00 ATMs. And if we add those all up, we get 15.00 total pressure. Okay, so now if I want the mole factor, I need to kind of rearrange this equation. So let me write it out for you. So whereas I have the total pressure of one substance is equal to the mole fraction times the total pressure, I want to get the mole fraction by itself so that I can solve for it. So I'm going to divide by total pressure on each side so that it cancels over there. So my mole fraction is equal to the pressure of one substance divided by the total pressure. Okay, so we're going to do that for each one in the question, because they asked what the total pressure was, which we found here, and they asked us what the mole fraction for each gas was. Okay, so I'm going to type it out. It seems to work a little better. So the mole fraction for, let's start with nitrogen, because that's the first one they gave us, and that's N2, is equal to the pressure of nitrogen, which was 10, divided by the total pressure, which was 15. And that's going to equal 0.6667 if you round. I don't know why it separated it. There we go. Okay. Now the mole fraction for the next one is going to be oxygen, which is O2, and that's going to equal the pressure for oxygen, which they gave me was 4 atms, divided by the total pressure, which was 15. And you're going to get 0.267. And then your mole fraction for the last one was argon, AR, is going to be equal to the pressure of AR, which was 1, divided by the total pressure, which is 15. And your mole fraction for argon is going to be 0.0667. Okay, and that's it for that question. Okay, we're going to move on to number 8 in your practice problems, which is an 8-point question on your test. So just a little heads up there. What is the volume of 32.2 grams of chlorine gas at 1 atmosphere and 25 degrees Celsius? Okay, I'm going to clear this out so we can talk about this. Remember, I told you to kind of make a list of everything they give you in a question, and then write what they're asking you so that you can kind of see what formula you're going to use. And again, that page at the end of your module that I just told you about, page number 410, you're going to want to just refer back to that because that's got the list of all your equations. So first, let's list out what we have. So we have 32.2 grams of chlorine gas, Cl2. They gave me a pressure. They gave me 1.00 atmosphere. Here we can write pressure. They gave me 25 degrees Celsius. I can't do degrees, but you know, that's a temperature. And they're asking for volume, okay? Well, if we look on page 410, let's see, what equation has all these components? And you'll see, if you look, that you can use the ideal gas law. Sorry, I said the wrong thing. The ideal gas law for this, because that's pressure times volume equals the number of moles times the R constant times temperature. Okay, so here we have grams, and from grams I can find moles. We know that. I have a pressure, I have a temperature, they're asking me for volume, and I have an R constant. So I can plug everything in here. So let's solve first of all for V so that we know what formula we're going to use. So what I would do is I would rearrange this to solve for V. So I would divide this side by pressure and divide this side by pressure so that pressure is going to cancel. So this is going to be my formula to solve for volume, if that makes sense. All right, so now we're just going to plug everything in. But first, I do need to change some things. Remember, our temperature needs to be in Kelvin. So let's go ahead and convert this to Kelvin. So we're going to do 25 plus 273.15 to get our temperature in Kelvin. And that's going to give us 298. We have to round to the ones place because they give me a temperature in the ones. No, they give me a temperature in the first decimal place. So I'm going to do 298.0. I'm following along in your book, but for some reason that's not making sense. Okay, well, if you get 0.15, that's fine. I don't know why they just did 298. I'm not quite sure. I haven't studied on that. Okay, you'll get 298.15. So let's just use that. Okay, so, and that's Kelvin. All right, next, I need to convert my grams to moles, right? So let's do that next. And I'll write it out here. So we'll do 32.2 grams of Cl2, and that's going to be over 1 times, I'm going to do moles on top because I'm going to moles, 1 mole of Cl2, and then I have to find out how many grams are in 1 mole by looking at the periodic table. This was just easier, sorry. Okay, and if you look at the periodic table, chlorine has a mass of 35.5, and then you're going to multiply it by 2 because it is Cl2. And once you do that, you're going to get 71 grams in 1 mole. And once you put that in your calculator, you will get an answer of 0.454 moles of Cl2. Okay, so now I have my moles, I have my pressure, I have my temperature in the right unit, and I have the R constant. We can go ahead and plug it in. So I'm going to just write it out for you. So volume is equal to the number of moles, first of all, so that's 0.454. I feel like it's better when I type it. I'm going to do that. I just like it better. It looks better. Okay, so I'm going to put it in parentheses. 0.454 moles. Okay, next is going to be the R constant, which is going to always be the same, 0.0821. Now remember our unit, you have to know this, liter times atmosphere divided by moles times Kelvin. Okay, that's my R constant. Now, ooh, this isn't gonna work. I need it to be on the top. Let me do a new text box. Next, I'm gonna plug in my temperature on the numerator. So it's gonna be 298.15 Kelvin. All right, and in the denominator, we have pressure. Whoops, sorry. See if I can do a better job. There we go. Okay. So as you can see here, pressure goes in the denominator, and pressure they give me is 1.00 atmospheres, which is really good because anything divided by 1 is the same. So really, I just need to plug this into my calculator. Let's make sure our units match up first of all. Okay, so I have moles on top here, moles on the bottom here. Kelvin on the top here, Kelvin on the bottom here. I have atmospheres on the bottom here, atmospheres on the top here, left with liters. Perfect, which is what we're looking for because we're looking for a volume. So we're going to plug 0.454 times 0.0821 times 298.15. And I'm going to get 11.113, which I'm just going to round to 11.1 liters. And that would be your answer. Again, that was an 8-point question on your test, but it's going to be just like this. So as long as you know how to do it, you should be good. All right, moving on. I might do, let's see, I'm going to count real quick how many questions I have left. 1, 2, 3, 4, 5. Okay, I think I'm just gonna do one more question, and then tomorrow I'll do the last 4 questions, so that this isn't extremely long. One last question, and I'm gonna let you go. I'm gonna go ahead and clear this out. I'm gonna work on number 9 in your practice problems. Okay. This is going to be a 12-point test question. Okay, so pay attention. All right, silver tarnishes in the presence of oxygen and hydrogen sulfide according to the following equation. Gives me a balanced equation. Usually H2S is the limiting reactant. If a silver spoon is placed in a container that holds 62.1 milliliters of H2S at 1.15 atmospheres and 23 degrees Celsius, how many grams of silver on the spoon will tarnish? Okay, So let's do what we did, what I said we should do before. We're going to list out what we have, we're going to see what they're asking for, and then we're going to think about what equation we might use. I think this would be helpful for you guys in determining, because sometimes I think you don't know what equation you're supposed to use, because it's a lot of information in the problem. So let's just list it out. Okay, so they give me a chemical reaction, so I'm going to write that down because that normally tells me a chemical equation for a reaction. That normally tells me I'm going to use stoichiometry in some way. Okay, so there's that. They give me 62.1 milliliters, which I know is a volume. They give me 1.15 atmospheres, which I know is a pressure. And they give me 23 degrees Celsius, which I know is a temperature. They're asking for grams of silver. The volume they gave me was for H2S. So if I'm looking at my equation here that they gave me, it looks like the silver is the Ag, so I'm going to put that here. So they're giving me a volume of one substance. They're asking me for grams of another substance. So remember, anytime you're going from the amount of one substance to the amount of another substance, you're going to use stoichiometry, okay? So this question is going to have a lot of steps, but we're going to do it together. All right, so I'm listing out everything I have. I know I'm going to use stoichiometry to go from one substance to another substance. So first of all, I need to figure out this. In order to do stoichiometry, I need moles, right? So because I have volume, I have pressure, I have temperature, I have all these things, I know that I can use the ideal gas law to find out how many moles I have. So PV equals nRT. Okay, we're just going to rearrange this to solve for number of moles. So I divide by RT and do the same thing on the other side. That's going to cancel. So my equation for N, for the number of moles, is going to be PV divided by RT. Okay, so let's use the information they give us to go ahead and figure that out for H2S, okay? So the first thing we're going to do is just plug it in. N is going to equal, the pressure they give me is 1.15 atmospheres. The volume, let's put that in parentheses just so we know. The volume they give me, 62.1 milliliters, but there's a problem there. I'm going to recognize, because I know, let me just write this out here for you, that R is equal to 0.0821 liters times atmospheres divided by moles times Kelvin. I know that I'm going to need liters, not milliliters. So first, I'm going to go ahead and convert that. So I'm going to put an arrow up here and we're going to convert. Okay, so that means I have 62.1 milliliters over 1 times, I'm going to liters, so 1 liter. And let me do another box on the bottom. This is going to be over 1. And I know that 1 liter is equal to 1,000 milliliters. Just write that out. Okay, so we're converting. So that is then going to give me 0.0621 liters. Okay, now I have the right volume. Now I'm going to go back over here. Trying to get this in the right spot now. Okay, volume is 0.0621 liters. Okay, all of that divided by R, my R constant, which is 0.0821 liters times atmospheres divided by moles times Kelvin times temperature. And temperature, they tell me, is 23 degrees Celsius, okay? problem, we definitely need it in Kelvin. So let's convert that over here. So we're going to do 23 plus 273.15. That's going to give me 296.15 Kelvin. Okay, so let's go back and plug that in the equation. 296.15 Kelvin. All right. So this is going to give me number of moles. So I know this looks kind of jumbled up, but in your calculator, 1.15 times 0.0621 divided by 0.0821 times 296.15. Okay. Once you do that in your calculator, your answer is going to be 0.00294 moles. Okay, so step one is done. I have figured out how many moles I have of H2S. So now I can do stoichiometry to find out how many moles of what they're asking me for I have, okay? So next step, we're gonna use stoichiometry. So I'm just gonna put step 2. So I have 0.00294. Let me erase this so you don't get confused. Moles of H2S, and I'm gonna multiply that by a conversion factor, okay? So this is gonna be over 1. You guys know how to go from moles to moles. We've done this a million times. So I'm gonna look at my chemical equation, and in the chemical equation, so I'm going to silver. So I see I have 4 moles of Ag in the chemical equation that they give me in the question. And that's going to be over the number of moles of H2S they give me in the equation, because I want that one to cancel. So I have 2 moles of H2S. Okay, so we're just going to put that in the calculator. You're going to put it in the calculator just like this. 0.00294. Let's do a parentheses, I apologize. Times 4 divided by, close your parentheses, divided by, I'm not going to worry about the 1 because remember 1 doesn't affect anything, divided by 2. That's the only other thing I have on the bottom. Once you put that in your calculator, you will get 0.0058 moles of Ag. Okay, and now that I have moles of silver, they're asking me for grams, I can easily convert from moles to grams. So we're gonna do that last. So here's my given value, which is 0.0058 moles of Ag. Okay, that's going to go over 1. And I'm going to multiply it by the conversion factor, which is going to be, on the top, I need to find out how many grams are in 1 mole of silver by looking at the periodic table. And it's 107.8 grams of Ag. And that's going to be over 1 mole of Ag. I know there's this many grams in 1 mole. And then my moles will cancel and I'll be left with grams, which is what they're asking me for. So remember, we have 1s on the bottom, they don't affect anything. So in your calculator, 0.0058 times 107.8. Once you do that, you're gonna get 0.634 grams of silver. And that was what they were asking me for. Remember, this is a 12-point question. So pay attention very closely to how we did everything here. And if you have any questions, please let me know. Again, thank you to the person who turned their homework in. You're doing a great job. Everybody else, I expect more. I know you're going to do a great job the rest of the school year. Let me know if you have questions about anything that was on the review today. I hope you do watch this video. It will help you on your test. We will finish reviewing tomorrow. I have about 4 questions to do tomorrow. And then most likely your test will just be for homework, and I'll be available if you have any questions for me. So just let me know. I'm always available to you guys if you need me. I miss all your faces, and I will see you tomorrow at 9. Bye.